demonstrating meta-analyses. And so today we've got a set of folks who presented their own meta-analyses. And so we're going to get their perspectives on their experience with the process, benefits that they see for their careers, let's be frank, and also for science, some costs of what might be considered a focus on meta-analyses, and maybe we can get into some of the implications for the field that maybe are not so positive by having meta-analyses. And then if we have some time, and I want this to be an open discussion with everybody who wants to address the panel, but think about what is it in marine systems that maybe makes them more challenging or easier when it comes to doing and publishing meta-analyses. So I'm going to start with an anecdote about the history of meta-analysis. When I'm an old guy, I went to graduate school in 1995, and I had never heard the word meta-analysis. For those of you in the room, that may surprise you. We called it a literature review. And we used to vote tally, essentially, in the introduction of our thesis, some process, right? And it really was the implementation of a couple of synthesis centers, one in Santa Barbara on ecology and one in the Triangle on evolution, where meta-analyses really took off, I would argue. It had been such a common theme to the medical literature, does a drug work, for instance. And so that's where we're at now. Let's see, let's start with Molly. Hey, Molly, you there? Okay.
I'm here.
So what I'm going to ask each of the panelists to do is just briefly describe your experience with meta-analyses, how many of you have been involved with, and what kinds of data you put together, just in broad strokes. And then I'd like for each panelist to tell the audience a meta-analysis that they were involved with or they read that had an influence on their science. That it was a good thing. So I'm curious to hear everybody's answer. So Molly, I'd put you on the spot, but I've warned Matt and Katie that they would have these questions. So I don't know if you want to go ahead.
Yeah, I can chat a little bit. So I started with a meta-analysis during my PhD. Before that, I also did not know what they were, where I quantified amphibian survival in saltwater across studies. And then that was really informative because it gave a general picture of what to expect in terms of when frogs die in saltwater, which was fundamental to my research at that time. Since then, I've done 3 more. I did the one working with Katie and Jeff, which incorporated the use of that COVE-GE metric and looking for that in the literature. And then right now I'm working on 2 more. I've sort of shifted back into amphibians. So I'm looking at the effects of stressors on amphibians more generally. And I'm also still thinking about saltwater and amphibians. So I'm kind of shifting more into those pockets of the literature. But there was a meta-analysis in 2011 from Richter Boy, it's B-O-I-X, et al. And this was revolutionary to me because they essentially took a lot of developmental data in amphibians and then looked at a historic selection pressure of how long ponds are filled with water, so pond permanency. And they looked at species that live in permanent ponds versus temporary ponds and came up with some really interesting evolutionary hypotheses about the drivers of amphibian metamorphosis. And it still to this day is one of the studies that I return to when I think about amphibians, which is, I spend a lot of time thinking about amphibians. That's one of the studies that really guides the way I think about amphibians to this day.
Perfect. Thank you. Katie.
This meta-analysis that I just presented is the first one that I've ever done. There's still a lot I need to learn about doing meta-analyses, because I've never used the traditional statistics that a meta-analysis uses. I guess the study that influenced my thinking, not necessarily my science, but my thinking, is meta-analyses that Rich Palmer did on fluctuating asymmetry. So, we're, as humans, our heart is always on the left side of our body, but flatfish, their eyes like migrate around to one side of their head and all of their organs adjust according to the way their eyes migrate around. And I learned from his meta-analysis that they don't always do it the one way. Like some species actually migrate in more than one direction, sometimes to the left, sometimes to the right. And he did a whole meta-analysis on this, and he used these what's called funnel plots to look at publication bias. And I was a graduate student at that time. I had never learned about publication bias in my undergrad. I hadn't really been a focus of any of the graduate classes that I had taken. So it opened my eyes up to the fact that, like, there is things that people publish because they notice them, and there's things that people notice but don't publish for whatever reason, and that we can detect that with analyses. So that would be the study that influenced me.
Okay, I feel better about my answer now because you've seen my only meta-analysis. And so that represent the thermal limit data is sort of what I've been focusing on. But I had a little bit of heads up about picking a good meta-analysis, and I had one that came to mind, but I'm realizing that it's not an actual meta-analysis, which I hope is illustrative of some of the questions that people will have throughout. But the Pace of Life papers by Andrew Hendry were super cool. They were papers that I was super interested in, and I thought had interesting results about response to selection and how that might vary to different factors. But it's not a true meta-analysis. It's not using the specific statistics that Katie just mentioned. So it's a data synthesis. Meta-analysis is a type of data synthesis, but all data synthesis is not meta-analysis. So that's
Okay, great. Thank you. I guess just to complete the circle, the one that I would point to is actually stemming from when I was a graduate student and thinking about herbivory a lot. And one of the things that I had taken as gospel was that herbivory rates and impacts were greater in tropical systems, and have a whole series of introductions that actually cited all the classic studies of how much herbivory gets taken off of coral reef, how much seaweed gets taken off coral reefs. And then I was part of a meta-analysis that showed that that's complete BS, that there are no latitudinal gradients in herbivory impacts. And that really had a big impact on me. And it's the thing that I always go to whenever I hear about the challenges involved with meta-analysis. It's like, well, there can be insights if it's done in the right way. And so with that, I want to sort of shift to challenges. So challenges in implementing or doing a meta-analysis, and then maybe challenges in interpreting them. So let's start with Matt. So in putting together this meta-analysis, what was the biggest challenge that you ran up against?
Yeah, so as a reminder, our meta-analysis was collecting thermal limits for multiple populations, and then looking at how they vary across latitude. But the true meta-analysis was looking at the effects of maximum temperature differences. And I think the biggest, so there were two classes of issues. There were group issues, which was how do we find, sort, and then extract data from the published literature, ranging from, I think, like the 60s to today, when formats of reporting data have changed over time. Data archiving did not happen earlier, whereas more recently it has. And then there were the actual analytic challenges in terms of learning a whole new set of statistics that I never really dug into before. So that was fun to do, sort of at the end of a PhD, realizing, okay, there's a whole other world of statistics that you have to learn and become comfortable with. And
I can
Go ahead.
speak I can speak to the practical difficulties of a meta-analysis. When you're diving into the literature to pull data, it becomes very obvious the diversity of thought that authors have, just in the way that information is presented. And also, you know, sometimes you just forget to put in your sample size. And when you're doing meta-analysis, those issues rise to the surface quite quickly. And they can really be difficult to know how to deal with as you're going. And oftentimes you're sort of chunking your data extraction. And if you hit it towards the end, it's a total headache in trying to figure out how to handle some of those issues. So I've always had the most trouble with these practical extraction issues.
Yeah, I'll just add to that. I think the two major challenges are the first one is like setting the criteria for the data. You have to say like, okay, we're going to use studies that measured this and also collected this data. And, you know, if they filtered, they'd use these filtering criteria or, you know, and they reported their sample sizes. So you have all these check boxes. And it's like enormously time consuming to go through every single study and check every single one of those boxes. And that's the part that, you know, we always use 1 minute in our presentations to present, but was probably the most time that we spent in the meta-analysis, is just getting the data into a format where you can actually do the meta-analysis. And then the second challenge is like how to summarize that data in a meaningful way. So, you know, we had to create our own statistic. Matt had to learn new statistical techniques. It's a huge, huge challenge to figure that out because it's not the same for every meta-analysis.
And just to add to what Katie's saying, some of the more standardized and popular ones like Hedges D or log response ratio, they actually still come with their bag of biases and issues themselves. So you can't just slap, you know, oh, I heard about this, so I'll use it. It's still something that has to be dealt with in a pretty intensive way.
So let's think about and I'm open it up to anyone. If anybody has any thoughts or questions, please raise your hand now. But I guess I wanted to think more about the costs or the challenges when it comes to focusing on meta-analyses in terms of advancing science. Do meta-analyses always advance our knowledge of a field or of a question? And if are there cases in which it might have impeded the progress of a field? I'm curious if anyone has a specific example in mind. Okay.
So I have a couple. Dan Bolton, I guess. So one is, I'd say, speaking as editor, occasionally we get meta-analyses submitted that we have 8 data sets that we put together. And it's like, well, maybe we should wait a little while until there are more studies. So I'd say one answer is premature meta-analysis. Another is Andrew Hendry presented a different meta-analysis, not the one you referred to, at the American Naturalist meeting in 2019 or 2018. Anyway, it was 20 something. And he presented some results, and I was chatting with him afterwards, and he commented that actually a lot of the average effect size was very sensitive to a couple of outlier studies. And it turns out those outlier studies were published by a now infamous spider biologist. And I had to say, you might want to hold off on submitting this paper a little bit because, you know, I happen to know at the time that he was present, this was just when this was starting to rumble in the background. And so that was an instance where a meta-analysis that a lot of people were excited and talking about at the conference probably would have been retracted or significantly modified on the basis of flawed data. And so I don't know how to deal with that, except that sometimes if your result is sensitive to a couple of outliers, especially if they're outliers from a particular author, that's a red flag.
Please state your name.
This is Allie Kramer. Yeah, kind of following up on what Dan said, I was curious. So I've done data synthesis a lot, but frequently the data I'm working with aren't applicable to the standard meta-analysis format and can't be weighted in kind of that data quality component that's so crucial to meta-analyses. But I've always wondered, how do you incorporate author difference? Because that is like, yeah, the end matters, but the author matters. Like, is there a way to weight it by author so that kind of problem Dan mentioned isn't necessarily a thing, or is that already integrated into the standard meta-analysis framework?
I think the answer is yes, but I'm not a master on this. I imagine that one of the things you can do is quantify the effect of specific authors.
I have
This
used
is-
study as a random effect.
So is study always used as a random effect? Like for each of you, is this considered in your meta-analyses? Yeah, or right. Yeah, that's right. Do you use author as a random effect?
I've used study.
Yeah, so have I.
Yeah.
But this does raise a broader issue, which is you're using someone else's data. And so you should always recognize that you're using someone else's data. And I say that in two ways. One, because you're trusting the veracity of that data. You're trusting the integrity of that data. But secondly, from a publication perspective, it used to be that meta-analyses were done and no one would get cited for having when their publication was actually used inside of the meta-analysis. And that changed for several journals, I think about 7 or 8 years ago. I don't know if AMNAT does that or has done that for a decade. And so that actually, I remember in the early aughts that caused a lot of consternation because you ended up with meta-analyses that got heavily cited based on really hard fought data that also had the same effect at the end of it, but would not get cited, you know, and so that is something that from a scientific from the perspective of career building, you want to have publications are often what we use as currency. And I know that is, I'm glad now that we give actually that currency to the people that generated that hard fought data. So comments?
Just continuing on that, this is Dan Bolnick again. One of the nice aspects of Data Dryad as a data repository is that it creates a DOI that's citable. So in principle, you can cite the data repository. And when your data repository gets cited, that can show up, you know, that's something you can put on your CV, can be part of your metrics. So it's part of the logic of Dryad is a citable data. The other thing I wanted to add real quick is phylogenetic comparative analyses and meta-analyses are interrelated, but often don't talk to each other. And I have had one meta-analysis that I published that somebody then took and said, but they left off phylogeny. And we should do a phylogenetic, the phylogeny should be in effect a structure in the covariance matrix. And I think most ecological meta-analyses omit phylogenetic non-random distributions of traits and effect sizes. And arguably probably should, like if your data set's dominated by a bunch of frogs and then other things, that's going to generate a bias, and we tend not to effectively deal with that. So think about phylogenetic structure in your data sets as well. And I think that's starting to percolate a little bit.
I'm actually really sad that you brought that up because I've been thinking about that as a problem in our CoGE meta-analysis, in that I don't know how to control for phylogeny with the statistic that we've developed to measure it. And I'm afraid we haven't submitted it for review yet. And I'm afraid when we do that, that the reviewers are going to pick up on this fact and potentially, you know, say that we have to do this thing that nobody else has done before. And I don't know how to do it. So maybe that's a problem with, with meta-analysis. Yeah. Yeah. But Matt, in your meta-analysis, I was wondering, like, you you have the marine versus terrestrial, but how much is that confounded with like vertebrates versus invertebrates or ectotherms versus endotherms? Like what are those random effects?
Yeah, so we lucked out in that there's no endotherms in our data set. So we're only dealing with ectotherms. But we include broad taxonomic groups in our random effects so that it's we have phylum. I think we left off at phylum because the distribution starts breaking down after that. But yeah, so we account for that as much as we can without doing an actual phylogenetic correction.
Hi, this is Camille Rumberger. This might be kind of a basic question, but could somebody explain the difference between a meta-analysis and data synthesis?
Who wants to tackle that?
Matt, you seem to have a pretty good grip on it.
So the broad definition, everything is aimed at taking data from multiple sources and getting to some larger insight. A meta-analysis, though, is really specifically weighting contrasts, weighting comparisons by the error or the variance associated with those measurements. And so you're assigning more value to more precise measurements, which is an issue if those super precise measurements are artificial. Whereas a data synthesis, you're just combining data from multiple sources, and it can be in multiple different forms. And so, for example, the paper by Jen Sunday that I talked about earlier this afternoon is a data synthesis. They have really nice stats associated with that, with nested taxonomic information in the models, but they don't consider error associated with those thermal limit measurements.
So maybe Rachel's and the working group's report on genetic diversity was a data synthesis, but not necessarily a meta-analysis. It's not using those weighted effect sizes. The distinction seems pretty small to me.
This is Ali Kramer again. So just following up on that, like the distinction is small, but it's often limited by the data you're working with. So you can really want to do that meta-analysis where you get that beautiful effect size and you can really look at it. And depending on what you're doing, you might not be able to do that at all. But you still, especially if you're working in a management context, you still have to draw an inference. You do try to take into account biases in your synthesis, but it's not as formalized, and it's not, in many ways, it's not as robust as being able to do a standard meta-analysis, but it's just very data limited.
Yeah. So Rachel says, I like to think of the difference as analyzing the data in a new way, which is the data synthesis, versus looking at effect sizes reported in papers, which is a meta-analysis. And the effect size, that is a statistical term looking at the magnitude and error associated with a measurement, right? So not every data can be meta-analyzed. And so, for example, from thermal limits or ecophysiology, there's multiple approaches. So for thermal limits, you have something called LD50, which is survivorship at multiple different temperatures. You take the temperature where you get 50%. So it's hundreds of individuals for one number, right? Whereas something like a CT max for an individual thermal limit, you can have 30 measurements. You can meta-analyze CT max really easily, but unless you're measuring multiple independent survivorship curves, you can't meta-analyze LD50 values. And so I think in our collection, the only LD50 values that we meta-analyzed were from Morgan, who put a lot of effort into her experiments with Tigriopus. So that makes a big difference for meta-analysis.
Shout out to empirical data. Any other general comments? I have other questions I can pop for the panel, but any other general comments or questions, or anyone who has another example of a meta-analysis that impeded the field. Maybe you don't even have to say what the article name was.
Do you have an agenda, Eric?
No, I don't. No, this is all a discussion amongst friends. We're all friends.
This is Sam Bogan asking the question. And my question is probably aimed at Matt, but also for anybody who wants to answer it, like thinking about CT max as being your outcome variable and all of the experimental variation that can go into an assay for CT max. What's your ramping rate? What is your recovery time after the CT max assay? On and on. How did you find yourself navigating what experimental parameters to consider, what to leave out, and just like what's the story behind thinking about those as covariates in the study?
I appreciate the time so I can think about my answer. Yeah, so this is a really important point. And I think someone in the sort of language panel this morning said you have to really know your data in order to talk about it. And it's the exact same thing with meta-analysis, where there's all these factors that will affect measurements reported in a paper that might not be emphasized as key factors. So in something like a CT max experiment, how quickly you're increasing temperatures, how long those temperatures are, or how long you're observing for, you're looking for recovery afterwards. And so the paper by Jen Sunday does a really nice job exploring that parameter space and which parameters are important. And in their statistical models, we took a much more generalized approach because our contrasts were looking at differences between populations and not comparing between studies necessarily. And so we're assuming that latitudinal patterns are not going to be affected by something like a experimental or methodological covariate. But it would definitely be super important if you're comparing sort of apples to apples to apples. Like that.
One of the values, and sort of jumping on what Matt was saying, is as you're looking at these data, oftentimes we go into this sort of naively expecting things will be a little bit easier than it is. But something that I have found is if you pay attention to those things that you weren't anticipating to come up. So for example, with my work looking at saltwater and amphibians, something that keeps coming up for me is as I'm collecting my data is, okay, well, there were 20 in this tank, 40 in this tank, 1 in this tank. And so I'm thinking about, well, I wonder if density mattered. And so if I'm paying attention to those things as they come up, that actually might be an interesting question unto itself. That maybe you can't answer with your current meta-analysis, but if you're thinking and being aware of these differences, maybe, you know, those issues as they come up could be informative for future studies or future questions.
This is Sarah Jean Wolfson. Kind of related, do you think that meta-analyses help correct or help point out bias in the literature, or do you think that they kind of gloss over bias because it's like, oh, look, here's the answer, okay, we don't need to do more studies?
That's a great question.
There is a developed framework for identifying publication bias, and it's called a funnel plot. And I don't remember exactly how it works, but on the x-axis is basically the effect size, and on the y-axis is the amount of error or your sample size. So as your sample size gets larger, you expect everything to converge on the correct effect size. And as your sample size gets smaller, you expect more spread around that effect size. If there's publication bias, what you see is not that funnel shape, but like a half funnel. And so there are these quantitative methods developed for identifying publication bias, but they're not really applied in most of the like highly cited meta-analyses in the last 5 years that I can think of. And it's not always clear how you would apply them. So for example, that's usually based on like comparing a treatment where a drug was given to one where it wasn't. So it's always, those are really effective when you have like a simple treatment versus control. In our case, we have this like 2-dimensional distribution of cove GE versus G by E. So I guess that at least we cover the whole parameter space. So maybe there's no publication bias. But then as Nina pointed out, like, well, if people aren't looking for it, there could be a lot more density in this one area of the space and nobody's published it. And there's not quantitative methods for us to be able to determine that I can think of. But yeah, I think publication bias is a huge undefined problem in meta-analysis.
Yeah, building on that, in addition to publication bias, your own bias in terms of search terms makes a huge difference. And so for our meta-analysis, we ran an initial search string that required studies to mention local adaptation, because that's what we were interested in. But we had a reviewer who gave us a fantastic comment, which is, why are you assuming papers are reporting local adaptation or reporting differences in thermal limits in the context of local adaptation if that's not the theoretical expectation for something like a marine system with lots of gene flow? And so we redid our search and found another 500 studies or something, included a couple dozen. It didn't change the results, but it was one of those like light bulb moments where it's like, of course, like we're looking for studies that are reporting local adaptation. You're only going to write a study, or you're only going to write a paper on local adaptation if you found differences, right?
You might have noticed that Matt said we redid everything. And I've had that experience too. And I don't know about you, Molly, but it's every meta-analysis, you reach this point where you like collecting data and you're like, oh, we should have collected this. And so you go back through every single study again and quantify that thing. So make sure that as you develop a meta-analysis that you're developing it in a framework that is reproducible and well organized. I know Molly used our code to create a reproducible search terms, and even that reproducible search did not come up with some of the studies that we thought should have been on that list. So we had to add additional criteria for, studies that were published in other papers to add to that list. I don't know how you guys made yours reproducible.
Yeah, we specified it in the methods. And so but I think part of the reason this is tricky, the search strings, is you have to balance including all the studies that you want to include and not getting 40,000 results that you then have to manually filter. And so I think that walking that line comes down to, again, knowing the literature and knowing how are people reporting these values, and can we figure out a string that incorporates every paper of interest, but leaves out as many of the ones that aren't relevant.
I'm actually curious if anybody knows, like we all know, social media has algorithms that show us what they think we want to see. I'm curious, is Google Scholar working off a search algorithm like that? Does anybody know if Web of Science or these places have algorithms that would affect what studies we see?
The answer is yes.
Yeah, and so this was another eye-opening experience where we did replicate Google Scholar searches at one of those tables and got not only different top results, but different numbers of results between computers and whose university's VPN we were using. So all of that is standardized in ours, where we had one person do the search every time. In Web of Science, because that one does not use an algorithm. So that's much more precise and reproducible.
I wonder if that's worth reporting now, is not only where the network you used, but also, we use, the search engine that we report that, but I wonder also if VPN is something to consider.
Following up a little bit on the publication bias. So if these approaches are able to negate the issue of negative results not getting published, or do we still have those negative results not getting published influencing these meta-analyses? Because that's always, when Sarah said publication bias, that's the one that came to my head first. The what did Rumsfeld say? The unknowns. what you're analyzing are publications, right? So, and we know the biases that are there. Let's see, we had a Jamie and then.
This is just a quick comment, but if you're using Google in any of its forms to say, suggest to a class what to Google or doing a meta-analysis, it's always a good idea to put your browser into incognito mode. Google's not that aggressive about tracking you if you turn it off. And the other thing you can do is just go to the library and use one of those machines. It will often be very instructive. I told my students I could Google things easily, and it turned out that Google knows me and returns oceanography.
Thank you, Joaquin Martinez. The question that I had is following on your comment about the publications. Why do you only search publications and not data repositories? Because again, as more foundations, and I'm not talking about NSF only, the more foundations, Science Foundation, there are more push for PIs to make their data available. Not always result in a publication, but the data is there and the metadata is there as well. So have you looked into how search those? Because if they're not published, they're more obscure, but how do you get into that data?
Great question. Anybody want to tackle that? Matt, I should have you just follow me.
Yeah, I think it's a super important direction as more sort of government or agencies require data archiving. For us, in our specific point, we loved it when a paper would archive the data, but we still had to screen the paper itself for the methodological details that maybe weren't being reported in the archives. We also ran into the issue where the vast majority of our studies had not archived. And so our sample sizes would have been even smaller if we'd only gone off of archived data.
With a recency bias.
Yeah, yes, exactly.
You know, the kinds of data that I've uploaded to BCO or Dryad are successful experiments, but you know, there's an enormous number of surveys that are out there that are publicly available. I think those have less publication bias because they are they are what you found. I think from my own perspective, there's so many reasons why an experiment could have failed. And so I do feel like this publication bias may be stronger with experiments than it is with surveys. I don't know if people agree with that, but.
Yeah, I just kind of have a
Hopefully-
general question.
Oh.
Go ahead. No, go
Sorry,
ahead.
I was just going to say that hopefully some of this changes. Some of the studies I've been looking at, the authors will be like, we didn't see an effect in survival. So, but I'm like, well, what was it anyway? And I do notice that newer papers tend to report the data, even if there wasn't a significant effect. So hopefully we do see improvements there.
So this is Ali again. General question, maybe some people know. I know that search engines are looking for particular things. And when I've done data synthesis, it's actually very hard to find things on data repositories. If you go to the particular repository, they have their own search, but it will not show up if you're using a search engine, even if you say explicitly, you know, in quotes, from this location. And so like, is there something that we can be doing in our own repositories, like maybe some sort of metadata file or maybe something that Nicodemo could put out, like that would make it searchable? What are search engines looking for?
I don't know how Google deals with Dryad or BCO DMO. I don't think they're easily accessed.
I have heard some good mathematic demos that are continuously improving. That's something that I understand works with secret and how to improve that. But it's also important to get this kind of feedback directly when you're depositing your data. They're willing to work with PI. And also it's our responsibility as PI to make sure that we just don't dump a bunch of. I spend 3 days, a couple of weeks ago, like making sure that the data that I was putting in Beacon made sense. It was well done to make that, just put the FSC file and check for anything. So it's our responsibility with methods and the things that go with it. So
Yeah. Molly points out we need the professional university librarians here to answer this one. Yes.
That was Rachel. Sorry.
Oh, you were thumbs upping. Okay.
Yeah, I was thumbs up.
You think I'd know Zoom after.
I have a question that's just for thought, but like we've heard a lot of challenges. And for me, I'm like, oh my gosh, I'm never doing a meta-analysis. This just sounds awful. So should we be doing meta-analyses? Like what's the value? Because I think Erik's biased us completely. But Molly, I'm gonna start with you. Should we be doing meta-analyses? What's the value here? Or should I just go measure these things with?
Yes, I believe fully in meta-analysis. One of the biggest things, there's two things that I think meta-analysis can do and serves a really nice purpose for. A lot of times we sort of get into these dogmatic ideas where we start cataloging. So we are all separate labs cataloging, say, we're dumping oysters in higher acidity water, but it's being replicated many, many times. And on its own, those data are interesting, but really what we want to do is, okay, is acidity having an effect on oysters? And meta-analysis is, I think, a really powerful way to do those projects in such a way that an individual could not do on their own. And then the second thing is that some of these projects are really experimentally intractable. For me and my interests, I want to know how all frogs are doing in salt water. I can't go get all frogs and dump them in salt water. One lab cannot do this. So meta-analysis is really useful to look at those questions that you can't really bring into a lab. And then finally, I will say that, and this was just fortunate, my meta-analysis with Katie began in 2019, and what happened in 2020, labs shut down. Meta-analysis was essentially what allowed me to continue through a period of forced laboratory shutdowns and allowed me to continue working through that. So, hopefully that doesn't happen again. Hopefully that's just a unique benefit, but it was really useful and fortunate to have the meta-analysis at that time.
I had actually just Morgan Kelly. I just have actually a comment also on Joanna's question, which is actually just to plug Matt's meta-analysis again. Just to say that I think that sometimes with our individual data sets, we can't see the forest for the trees. We sort of are looking at our individual system. And something that I think is really cool about this thermal tolerance analysis is that 20 years ago, there was this assumption in the field that local adaptation was rare in marine systems and certainly more common in terrestrial systems than in marine systems. And at least for LT50, it looks like thermal tolerance is stronger in marine systems than in terrestrial systems. And I don't think we knew that until this meta-analysis. And so that's an example of where there was sort of a common wisdom that was not true. And the meta-analysis was really important for demonstrating that.
All right. I have one final question. It's going to be an uncomfortable question, of course. So the question is, not all meta-analyses succeed because the process of getting people together and do a meta-analysis just doesn't yield it. In fact, the meta-analysis I was involved with here did not. So I'm curious about what people's thoughts are of what's the essential ingredients for getting together a group that makes a successful meta-analysis happen. I have some ideas, but I'm curious from the panelists. I'm going to put you all on the spot on what it takes to make this happen. Because as Joanna said, it's a lot of work.
To me, it's specificity. If you are too general, your meta-analysis will just die the death of 41,000 studies. So that's key for me.
I don't know if this is key or not, but it seems to me that when you have one person that is in charge of the data, like collecting the data, curating the data, maybe you have multiple people like looking at different studies, but one person is in charge of making sure that every single study is good and should belong in that meta-analysis. I think that helps a lot, because when you have, it's like having too many cooks in the kitchen, you know, Johnny's doing this, Joe's doing that, and then you get 350 studies and you're like, oh, those two weren't doing exactly the same thing. And so you start all over again, or the group falls apart.
Yeah, so I have n equals 1. There's no effect size for I can't meta-analyze this, but and there's a little bit of a survivorship bias because I've only ever worked with a group that was fantastic. And so it's but yeah, I think that the specificity, so we had a very distinct question and what I think are straightforward criteria for inclusion that made it easier to screen our papers. We wrote out like an extraction protocol so that it was just follow these steps to extract the data. We all shared interests, complementary interests that I think helped a lot too. A lot of the people in our group are interested in thermal limits, and so asking someone, can you take this paper that has 120 data points that you'll need to click and extract from a graph, might have been more tolerable since people were interested in that. But yeah.
And just to add one more thing, just regular meetings. I mean, it sounds simple, but before you end a meeting, like make sure the next one is scheduled on the calendar. Because if you're like, okay, everybody do this, and in 3 months we're going to get back together and everybody's going to have this data collected and we're going to go over it. That's just a long time to not be in connection with other members of your group and see that people are making progress.
Well, to defend our group, I will say that we had a fantastic group. We had a great set of questions. We had meetings scheduled. We just didn't, what we didn't have is the element that you said, Katie, which is one person to really steamroll us, to push us. And often that's the postdocs and the grad students, because us old people have a lot of other things going on. And so that to me was the crucial element to it. Dan, did you want to say?
Us postdocs have nothing going on.
Yeah. As a model for this, SDiv in Leipzig, Germany has working groups, and every working group comes with a, I don't know, 1 or 2 year salary postdoc. And so you don't have a working group unless you have a postdoc. And the postdoc's job is to make sure it happens.
Another important thing, just to kind of jump in here with what we were talking about earlier today, all my successful meta-analyses have had a devoted data set to definitions. So either a tab that specifies like, oh, this column header is N, well, what is N specifically? And defines it, so that if multiple people are pulling data, there's a clear what to pull in that column.
Okay, any other final questions, comments for the panelists or for the group? Okay, well, let's give a nice round of applause to our panel.
All right, and let's give an applause to everyone from today. It's been an amazing day. All right, so dinner is at 6, and then we will have our informal discussions about how to initiate collaborations and everything at 7. And people online, there will be an online discussion for you at 7. So everything has been moved an hour earlier because we can't do a boat ride under these conditions. So dinner's at 6 and our informal discussion will be here at 7.